The goal of this video is to talk about block distribution and Gibbs transition.m. Before I do that, there's one important helper method that's important for us to understand, which is log probability of joint assignment.m. Let's read what it is doing. It returns the log probability of an assignment A in a distribution defined by factors f. So let's try to understand what is this in a distribution defined by factors f. If you remember back from week 1 or week 2, you had a joint distribution over DIGSL, and that's defined by product of these factors like this: P of D, P of I, P of G given ID, P of S given I, P of L given G. So this right side part, these are your set of factors. So this distribution P of DIGSL defined by these set of factors. So that's what that is. And how would you compute a joint assignment? Well, basically you take the assignment and assign to these variables DIGSL and compute this product. Now here, since we are talking about log space instead of product, we are doing a addition. So that's the most important thing to remember. Let's go now to block log distribution. What is this supposed to do? It's got input V, G, F, and A, and we have to return the distribution log BS. And so each entry in log BS is the log probability that the value is selected. Log BS is the probability of V given the current assignments. So X underscore, well actually, yeah, you can go ahead and read this. I'm just going to explain what this thing means, really is. So for that, let's go ahead and find this thing here in Octave. I've already loaded those values for you, the A, G, V, and F. Let's look at each one. V is that input to the variable that's passed to it. G is your graph. It's got names. It's got 16 variables here. That's your names. The cardinality of all of them is same, so you can assume that. Obviously edges and this weight to factor. This is the interesting guy. So what is this weight to factor? So G dot weight to factors of, so let's say if I say of V, which is 1, right, in this case, it gives you that. Now in your, so the important thing is, let's investigate what happens if this V is more than 1, right, instead of just, so if V only has 1, but let's say our V is like this, then what will happen? Well, let's call the same thing again and do that. So anyway, what is this thing giving you, this G dot weight to factors of V? Because V is variable 1 and variable 2, it returns you all the factors in the graph that have this variable 1 and variable 2. That's what that is doing, that line right there. Okay, why am I talking about this? For example, because it actually cost me quite a lot of hours. So if I have temp equals like that, right? See what will happen. Your temp will only contain that 1, 17, 20. It doesn't have the 2, 17, 18, and 21. Remember that. So it's very important. So if you are writing code like this, don't assume and assigning it to one variable like this, you'll only get one value, not the other one, and you'll miss it and you'll spend hours. And in fact, the sad part is it will pass the test here, and then I think when you're doing the transition one, or then you'll realize that this is wrong, and you have to go and update. So even though here in the comments they said use only one for loop, somewhere here, I actually, in my case, I actually used the for loop to get my matrix, all the variables. So I just looped through all these factors, and you know, and I was able to handle multiple variables in V. Anyway, so the G2 dot where to factors. So for given variables, it'll give you all this set of factors that contains that V. So what is it that you have to do? Well, like I said, the D is you can assume that it's same for all variables. Now look at how they're initializing this return value, which is the um, block log distribution to one row and d columns, the cardinality of the variable in G, of any variable in G. So what is it that you have to do anyway? So, well, like I said, make sure you handle multiple variables in V properly. Once you actually, the reason this is called block is because this should be able to handle more than one variable, block of variables. Okay, that's why it's called block log distribution. So V is, so we know V, you just loop through this variables, right? And you get all the, make sure that you get all the factors associated to that in that variable. Even if it's greater than one variable, you have to get all the factors. Once you get all the factors, it's easy actually. All you have to do is you already have this nice little function here. If you pass it to factors and assignment, it'll give you the log property of it. So what you have to do is just loop through this D, and then for E, and most importantly, what is it that you have to update in the A when calling that log probability of joint assignment? You have to just update the A's for the variables in V, right? If variable is 1, then you only, when you loop through, you only update that to the corresponding index of A related to that V. So if, right, if variable is 1 and 2, then you have to update the A for that 1 and 2 only, keep the others constant, and then call your log probability of joint assignment. One other thing they're also saying is use unique and all that. So the reason they're saying unique here is basically if you have, because you know how that where two factors return set of factors for variables in V, and if you have duplicates, you want to make sure you just pass the unique factors. Good luck. Sorry. So there's one last thing I want to talk, which is the Gibbs trans. It's pretty easy. All they're saying is use this rand sample. If you look rand sample, actually I'll stop here and talk Gibbs.